Hey everyone. Again, my name's Chris Hendrick, and today I'm going to be talking about using D3JS for making maps for print. Again, I currently work as a UX engineer for Google, doing data visualization work in Google Cloud. But I have a background in cartography and GIS, and that kind of led me into this work I'm doing now. And this presentation comes from a project I did last year where I wanted to test out what this workflow might look like. So hopefully somebody finds it useful. So really quickly, what this talk will cover. I'm just going to talk about what D3JS is and why use it, some tips and tricks when you know that print is your desired output, some caveats to this approach, and a list of resources at the end. And I'll provide a link to these slides for that. So D3JS for print cartography. If you haven't heard of D3JS, it's the three-part stands for data-driven documents. In other words, it's a JavaScript library that gives you tools for rendering web pages, a specific type of document, using various types of data, such as tabular data or GeoJSON. I think most people often associate D3 with making these kind of like slick, interactive, and dynamic, bespoke visualizations for the web, such as this one by the very talented Nadi Brummer, titled Royal Constellations, which is kind of like a temporal family tree of how different European royal families are related to one another. And as you like hover over it and like click on things highlight and animate, and it's just a really beautiful thing to interact with. So it's typically, D3 isn't typically thought of for making static graphics for print. However, many news outlets do use it for that purpose, and there's a good reason for it. The first is D3's output of choice is typically SVG, or scalable vector graphics. And if you look under the hood, SVG is just markup similar to HTML that describes how to draw something. And on the right, you can see the markup for this logo from Wikimedia. And I know it's really small, so you can't read it, but if you were able to inspect it further, you'd see that it's fairly human readable and uses a Cartesian coordinate system. And in a browser environment, these SVG objects or tags are first-class DOM objects. In other words, they're well understood by web browsers as well as vector editing software like Adobe Illustrator, which means it's very possible to transfer SVG between browsers and vector editing software, which I think some people have already demonstrated here today. The next reason you might want to use D3 is because of D3Geo, which is the part of D3 that handles a lot of the geospatial functionality and cartographic design functionality. And to me, the two biggest advantages of D3Geo are that it consumes vector geographic data and then will output complex SVG paths, and it offers a wide variety of map projections. This is a screenshot of observablehq.com, and if you haven't seen D3Geo examples, you can go there and just type in D3-Geo in the search window. And I encourage you to explore some of those. They're really neat. But D3 has other helpful non-geo-related modules you can use that are actually helpful for creating maps. One is D3 Scale Chromatic, which integrates a wide range of color palettes that are very suitable for thematic mapping. For example, every color brewer ramp is built into D3 Scale Chromatic. And in conjunction with D3's concept of scales, you can use it to style your data dynamically without having to do a lot of manual mapping of color to data values. Next is TopoJSON, which refers to both a data format and a set of tools for converting data to and from that format. And it's D3Geo's close cousin. With TopoJSON, you can package all of your map layers into a single file, then read them from that file in the browser and render the layers individually using D3Geo. And that's what I've done here. On the left is a base map that I've created from a single TopoJSON file. And on the right are all the layers that are packaged from that file and then I get extracted out. So things like land, administrative boundaries, places, roads, rail, et cetera. So this is all fine and good, but really what's the benefit for print cartography? Well, I guess in response to that, I'd say knowing a little bit of D3, like D3Geo and TopoJSON, can get you pretty far without GIS or cartography software. And then I'd also add that there's benefits to using code to create maps, like being able to ideate quickly, meaning you can make small changes to your code and quickly view the results. develop a repeatable workflow, rapidly prototype, document your process, and then also collaborate with others if you'd like to. Okay, so there's some helpful stuff to know when D3 is, when you're using D3 and your intended output is print. And the big question that first comes to mind, I would think for most people, is how do you get your map out of the damn web page? Well, one way is to use something called SVG Crowbar. And so SVG Crowbar is a Chrome bookmarklet tool, so meaning that you just grab it and drop it in your bookmarks in Chrome. And then when you click on it on a web page with SVG, it'll extract that SVG and download it to your computer. And this was created by the New York Times graphic staff. And they even recognize that using web-based technologies for generating SVG has a value for a print workflow. And so when you create SVG with D3, you want to make sure you keep it well structured. Well, how do you do that? For one thing, this means to not be shy using SVG G or group elements and ID attributes. So in this code sample here, I've highlighted parts of the code where SVG G elements are created and then ID attributes are applied. So at the top level, I have a group for map layers. Then within that group, I have a land layer. And then I have a county boundaries layer. And within that group, I have the top and bottom paths for the county boundaries. And the benefit of doing this is that when you finally export your SVG and bring it into a vector editing software, all of your layers will be kind of like neatly grouped and it won't be a mess. If you're somewhat familiar with D3 and also CSS, you might be tempted to apply styling using external style sheets. However, I'd recommend that you prefer inline styling over external CSS. And this is because when you use external CSS, you are prone to losing some of that styling when you export your SVG from the browser. So in this code, I've highlighted sections where I'm applying styling inline, such as fill color, stroke width, stroke color, and a stroke dash array, for example. This next one isn't so much related directly to print, but I think it's a valuable thing to know if you're creating maps in web browsers and you want to be able to reuse your code. And so say if you have a dozen maps that you want to make of the same area, but you might have a different data layer for each map, you can use HTML UI elements that we interact with every day on web pages to kind of help you with that. So for example, you can use a dropdown to select different views of your data. You can use buttons to toggle layers on and off, and sliders to filter or like even change the opacity of a color. So these things come in really handy when you just want to kind of play around and arbitrarily tweak your code without actually editing the code. And if you use observable notebooks, this actually becomes a lot easier and it's kind of abstracted for you. So what about arbitrarily sizing and cropping the map area? This is like a really common task that cartographers have to deal with all the time, and your map frame doesn't always align well with your geographic data. To be honest, this part is a bit tricky, but here you go. So what I ended up doing, and there might be a more efficient way than this, is after exporting the SVG and opening it up in your vector editing software, I drew a rectangle at my desired aspect ratio and framed the map. And then in the transform palette, change the origin to the top left and note the x, y, width, and height values. Here they're in points, but they're pretty much equivalent with pixels. And then using D3Geo's projection invert method, I can plug in those values and turn them into geographic coordinates or a bounding box. So up top is the coordinates from Illustrator, and at bottom is the longitude, latitude coordinates of my bounding box. Next, I'll create a simple GeoJSON line string feature, meaning just like a diagonal line from point A to point B. And then if I plug that into D3Geo's projection fit size method, I will have cropped my map. So that part took me a little bit to figure out, but I think it's super useful to do this before you export your map and start tweaking it in Illustrator, because chances are you might have to do something to your data again and then re-export your SVG, and you don't want to be constantly having to resize your SVG in Illustrator. So what does it look like when you open it in Illustrator? So here's my SVG file, and you can see everything is under one layer, but because I use those group elements and ID attributes, all my different layers are like neatly stored in groups and named. This makes it really easy to then copy and paste that into, say, like a template file, and then move things into place, and then apply, your styles from your template and do any kind of final editing. So from there, you can do things like adjusting the label placement, adding a title, a legend, additional text or graphics, and converting to CMYK color space. So there are caveats to this approach. I'd say for the most part, having to be familiar, at least at a basic level, with JavaScript, D3, TopoJSON, SVG, HTML, and CSS can be overwhelming or sound overwhelming, but my recommendation is if you're just starting on this path to pick one or two of those at a time. Khan Academy, for example, has a great free tutorial on HTML and CSS, and then move on to learning a little bit about SVG, then just a little bit of JavaScript, and that'll make learning the D3 parts much better. And one final tip for learning D3 is to just focus on one part of it. Don't try to learn the whole API, because that can be really daunting. So just think about what you want to do and then go from there. The next caveat is that the exported SVG is static. So that meaning when you open it, you lose all your linkage to your data. So if you want to change your data, you'll have to re-export it. If you have tons of layers, lots of raster data and detail, I'm not sure how this approach would hold up, but I think it's totally worth stress testing it. I just haven't gotten around to it yet. There are some SVG Crowbar limitations. I forget what they are, but just note, this workflow isn't perfect. If you are using observable notebooks, observable has a handy download SVG or download PNG button that you can use instead. And then finally, here's a list of resources. There's a link to these slides. I actually wrote more of an in-depth blog post on this topic. This was originally a 30, 40-minute talk that I reduced to 15 minutes. And there's a bunch of other links here. So I encourage you to check those out. And that's it. Here's the bit.ly link, bit.ly/NACIS-2019-D3JS-print-carto. Thanks.